Hi, I'm Jesse Sculley. I am a QT Industrial Design graduate of 2014. You'll be seeing my hands a lot more in the material prototyping videos. I currently work as a prop maker for Village Roadshows down the coast. The studio is right next to Movie World. I've been working on huge budget films, $200 million plus. Some examples are Thor, Ragnarok, and Aquaman. I'm currently on a film at the moment, but I can't tell you what that is. It'll be released in a couple of years, then we'll see it. Film work is somewhat seasonal, so when I'm not on a film, I am working in my industrial design business. I started this up a few years ago, and it's just a product design business. I do product concepts all the way through to mass manufacturable items. I also do a lot of 3D printing. I love 3D printing. As you can see, I have a few here right behind me. This one's my favorite. That guy there. What is a prop maker? I actually get asked this question quite a lot when I tell people what I do. Prop stands for property. So the property of the film, what you see on screen, what they own, all the rest. On a like a romantic comedy kind of film, they don't really need to make props. Set in this era, they go out and they buy the stuff. There's a prop master that goes and buys stuff and sources it. Whereas if you have a sci-fi film, such as Thor Ragnarok, none of that stuff exists. You need a whole entire department to make all the props for you. So, hence prop makers. We generally receive designs from the art department. It's full of designers down there. They create these crazy ideas of what they want to see on film, and they give us either a 3D model, 2D drawing, like technical drawing, or even just an artist rendition. I've received all three and had to make props off all three bits of information. What we do in the props department is we take what we've given and then we create our own 3D model because we're very heavy into digital fabrication. So we create our own 3D model in a manner of how we would fabricate it. So material thicknesses, types of material, processes that we want to go through. We will create a 3D model about that. And then we'll sort of break it apart and go and make all the pieces and then put it together. We're moving into digital fabrication more and more. The reason that is time and accuracy. So films are being filmed on 4K, which resolution is crazy, which means any close-up props are getting a really good looking at. So we need some high fidelity props out there, and that's only, people's hands can do that, but it takes time. So we're moving into digital fabrication such as 3D printing, CNC cutting, and laser cutting. So an example project I have for you guys is the Aquaman computer. That's what we call it. Essentially, it's a high tolerance, large set piece that prop department had to make. It sits in a larger set. This thing had cogs that meshed with each other, had to spin. We had columns moving up and down. We had other things moving inside of other things. So there was all sorts of tolerances and certain finishes on it. This project lasted 2 months and got about 5 minutes of airtime. So it gives you a bit of an example of how much work actually goes into a film that you just don't know about. Throughout the process, there's two guys working on it, me and the leading hand. Essentially, we created a 3D model. We got a design from art department, which is just a surface, just a look. And they said, oh, we wanted to do this, this, and this. And, okay, great. So we created a 3D model to mimic what they wanted and sort of see how we could actually make it happen and how the parts would fit together. So although we had a 3D model, we still needed to prototype some of the mechanisms in it because we had to worry about the sound it caused, because on set you don't want it to make a lot of sound because they're trying to record audio from the actors. So we were concerned with sound, we were concerned with weight, we were concerned with sizing because we only had a certain amount of space to fit it, and these parts had to move, so they couldn't weigh that much. So we actually made prototypes out of the actual materials we're going to use, but we only made small sections of it. So for example, there's a set of columns that all have to move quite independently. What we did was, it was about 250 columns, I believe. So we made a small version of it. We didn't shrink it down. What we did was we just did a certain part of it. So we did about 20 of these columns moving at the different angles. So there was a fully functioning prototype to show that it worked. We made adjustments from that prototype. We had the cogs also had to mesh. From the design, those cogs wouldn't have worked at all. They would have just seized instantly. So we had to redesign the cog teeth so that they meshed correctly. And also the material that was in between the cog teeth so it didn't make too much noise. So throughout that process, we had to prototype along the different stages. If we didn't do that, we would have had a whole heap of problems we would have to deal with at the end. Very not desirable. So we relieved the stress and we met the time frames because we did these prototyping stages along the process. Another example I have for you is what I'm currently working on. Well, it's in the film that I'm currently working on. So what happened is, art department came to us, props department, and said, look, we want this case, this technical case. We don't have time to design it. Can you guys design it and make it for us? And we said yes. So 3D modeled it. It's essentially just a hard case with a top that opens up, and inside there's a bunch of electronics and sensors and all the rest. It looks very technical. So we designed it, and that was great because that would streamline the process. You know, we didn't have to redesign it again because we knew exactly how we were going to make it as we're designing it. So that helped a lot. So did a 3D model of it, sent off some renders for the looks, and they said, yeah, it's great. We don't know how big it is. Can you make a mock-up? So what we did was, they wanted a mock-up for sizing because, you know, in the digital realm, you just don't know, you know, what the size of anything is. You can read dimensions, but until you have it in your hands, you don't understand. So we thought, okay, we have a 3D model. What's the quickest way to do this? My boss has a CNC router, so we're like, all right, let's cut it out of foam. So we CNC routed the entire 3D model out of foam. The fidelity was, you know, it's not high fidelity, but we CNC'd it, took it out, and it looked exactly like the case, just as in white foam. You know, the fidelity is a bit less. Didn't matter. So we had this size thing that looked considerably like it should. Gave it to art department, and they were, you know, looked over it and said, oh, we're going to make it smaller here and bigger there and all the rest. So we very quickly made the changes because it's foam. You could just cut it, add more, take some out. So that prototyping stage really helped begin the project. If we just went ahead and just kept making it and sort of ignored what they wanted and made a finished finished prop, gave it to them, and said, oh, this is too big, you know, that could happen, and it has happened in the past. So that very beginning prototype stage of sizing and form really assisted the whole project. All right, advice for students. I have 3 pieces of advice. I'll try to keep them short so you remember them. Observe and ask questions. When you're in the company of some very skilled people, observe what they're doing and ask questions as to why they're doing it. They have a lot more knowledge than you, and you need to appreciate that and take advantage of that as well. Next thing is experiment and play. You know, the experiment part to it, you know, play with materials, prototyping stages, design processes, experiment with that, you know, play around, make mistakes, that just happens, but play with it at the same time. So it's experimentation, but fun at the same stage. So mix those two together and your projects will be so much more fun for yourselves. And finally, the last bit of information I can give to you, advice, don't be disheartened when it doesn't work. This happens a lot. Things don't go to plan, and that's okay. You learn a lot more and you remember it more when you're making mistakes. So don't worry about that. All right, I will see you in the next prototyping video then.